Good morning, afternoon, Math 2 crew. We're now going to continue on 8.7, Notes Part 2, and I'm on page 463, Example 5. Now, the textbook uses a strategy that I'm going to avoid. So, the strategy here is similar to our previous strategy, and that is we want to take half the middle term and square it so that we can make this quadratic polynomial into a perfect square. So how do we do this? Well, the first thing we do is we know that we take the constant and place it on the right side of the equal sign so that we isolate the two other terms, the x squared term and the x term, on either side of the equation. So there we go. Now the difference here is that the x squared term has a coefficient of 4. Normally we had seen x squared terms have a coefficient of 1, and so they weren't even written like I wrote it out with the 1 there. It's just typically written as x squared. But that's not the case here. So we want to use the previous strategy, so that means we have to take this coefficient of x squared and divide every single term by 4, which is the coefficient of x squared. So the first step is to divide so that the coefficient of x squared becomes 1. So we divide every single term by 4. And that's the first step. Remember, the property of equality says that if you multiply an equation by a number, then you must multiply every single term in that equation by that same number. Okay, so I've done that. So let's simplify this if we can. Of course, this can't be simplified. Okay, now when we complete the square, we're looking for a number that we add so that the left side becomes a perfect square and factorable. And so how do we do that? Well, we learned that we take the middle term and its coefficient, divide it by 2, and that answer, we square it, and that gives us the number that we add. Okay. So the factored form here becomes x plus 1 squared equals, now, what's my common denominator here? It's 4. So if I take 1 here and write it as 4 over 4, that's okay, right? And so when we add, it's 21 plus 4 is 25 over 4, right? Yeah. Do not add the denominators. No, no, no. So let's take the square root. Right? Take the square root, end up with plus or minus solution, positive or negative answer. So reduce, we end up with x plus 1 equals plus or minus the square root of 25, over the square root of 4. And that's the quotient property. And so we end up with, let me subtract 1, 2, by the way. We end up with x equals negative 1 plus or minus 5 over 2. All right? Now, breaking these up into two possible solutions, I know that negative 1 is either, the common denominator is 2, so negative 1 could be written as negative 2 over 2 plus 5 over 2. Then we also know here that the other solution is negative 2 over 2 minus 5 over 2. And so working that out gives us 3 over 2. So that's one value of x. And here down low we end up with negative 7 over 2. And if you were to, you could convert these to decimals with no problem. But I'm not. I'm going to keep an exact form. So x is 3 halves or negative 7 halves. Okay, so again, the strategy here, I want you to pay close attention, was that we first divided by 4, right, so that the a squared term has a coefficient of 1. After that, we used the completing the square technique where you take half the middle term and square it, which is over here, right? And so we did that. We added 1 to either side. But then I realized that 1 has a common denominator of 4, right? 4 over 4. Since 21 over 4 is being added to 1, so we worked that in different form. After that, we took the square root of either side, right? The square root of either side. That gives us a plus or minus solution, negative or positive. Following that, we use the quotient property, right? We subtracted 1, right? Subtracted 1. This became 5 over 2. And here was our solution there, and then we broke it up into 2 parts to come up with each solution for x. That was example 5. The book does not show it this way, so I'll do another example. Example 6, again, write what you can in the margins the way I write this information down so that you have an idea of how to solve these. So, again, we've got a coefficient of 2 in front of x squared, so we want to get rid of that. So what's the strategy? Divide each term by 2. Okay. Now let's rewrite this in simplified form. It ends up being x squared plus 3x plus or equals 5 over 2. Okay. Again, our job is to find the value that we add so that that left side becomes a perfect square. Well, let's use our strategy again. Half of 3. We want to square that, right? So you can't change that, so let's just leave that as is. So 3 halves squared gives us, let's draw a little arrow here, gives us 9 over 4. Odd. So, with that said, that's what we add here. 9 over 4. 9 over 4. Okay, on the left side, the factored form is going to be x plus 3 halves squared. How do I know that? Well, I've said this before, that in the middle term, you take half of that, that becomes part of your factored form. And so that's the answer. If you want to FOIL and check it, you'll see that you'll end up with this solution. Now that's going to equal, okay, what's my common denominator here? My common denominator here is 4. So if I multiply this by 2, it ends up being 10 over 4. So I'll write 10, cross that off, put 4. So 10 fourths plus 9 fourths. 10 fourths plus 9 fourths is 19 fourths. Okay, let's take the square root. And so we're going to end up with plus or minus, right? And so we end up with this solution. It's x plus 3 halves equals the square root of 19 over the square root of 4, and it's still positive and negative. So clean this up. We're going to subtract 3 halves from each side. And so I end up with x equals negative 3 halves plus or minus square root of 19 over 2. Alright, so take a good look at this question and simplify it even further. So, we have a common denominator, look. See it here? It's 2. So we can add the numerators together, the negative 3 and the square root 19. They don't really combine, but they do simplify. So this would be negative 3 plus the square root of 19. Leave it in exact form. And then the other solution is negative 3. Oh, what did I just forget? What's the denominator here, guys? It's 2, right? So this is all over 2. My mistake. And over here, negative 3 minus radical 19 all over 2. And that's our solution in exact form without rounding up. So those are the examples that I wanted you to look at. Again, I wrote them differently than the book. Study them. Completing the square is really not that hard. Just some steps that you got to figure out, and then run with those steps. So we have opportunity to practice those today. Now I'm going to start up another video showing you some of the examples from your practice. So, like I always say, study hard and learn a lot, and we will see you soon. Bye-bye.